Gentlemen, this is like my 5th video here at J-Tech. Today we're going to be going over a myriad of different things, starting with the coil packs. We got a 2-prong and a 3-prong. So, how the 2-prong works is the same thing. It's like a Ford one, like what I have in my Expedition. You have the power and the ground that go directly into it. So, if you come over here to this little diagram, it'll show you, because it works in conjunction with the PCM. It has a transistor in there, so if this is ground controlled. So we'll go ahead and highlight this while we're sitting here talking. Ground control. So when you hit the ignition, you see how it's grounded here. Provides juice through the transistor, about 7 volts. It'll come down here, goes into there, powers the coil pack. So inside the coil pack, there's a big thick coil of wires. It's going to take the low voltage and create higher voltage. It creates a magnetic field, and it gets bigger and bigger, and then when the points open, and when the computer tells it to open, it sends a spark, which is a secondary right here with the boot on it. Sends that directly to the spark plugs, and that's what creates a spark for combustion in the combustion chamber. Some other components real quick we'll go over. You have a boot. You take it apart inside, you have the spring, which actually sits on top of the spark plug, which really it's going to make the connection, get the spark. And then you got the body of the coil itself. Moving on, we got the freaking power control. It's 3-prong. Same thing. Got the marker. Power starts here, goes down, goes down. So this is constantly on. This always has power. So when you hit the ignition, it closes. The power comes from here. Get enough juice by 7 volts, same as the other one. Goes through here, provides more power here, which is for the secondary one. Not the secondary one, and the transistor that's actually built inside this, and then it grounds out here separately with its own ground system. So that's a little bit the difference between a 2-prong and a 3-prong. Similar construction, with the exception of there is actually a transistor inside this one versus not one in this. Boot's a little bit different, but it's the same concept. It's kind of hard to see, but it's a metal grommet inside there that sits on top of the spark plug when you see it inside the top of the engine. Other than that, we're moving on to the next video. Pause. Part 2. Spark plug, gap tool, spark plug. So, very simple. What you're going to do, whatever the manufacturer recommendation is, you say it's, for example, this one. Sorry, turn it on the other side. It's 0.40. So it doesn't quite fit, right? If you can, it's kind of hard to see, but you can see one kind of, you want it to be kind of snug, but you don't want to be tight. So what you do is you take this little end here and very gently pry up on the end to get the desired gap that you want. It's a little bit too much, so you go back down and just press down a little bit, just like that. Perfect, right? Something to keep in mind is in different environments, most manufacturers will have just like one type of spark plug, as we all found out the hard way trying to look them up. However, for example, let's say you live in Alaska or you live in Fort Drum, New York or something. Spark plugs will have a different heat range, which means it'll either burn hotter or it's going to burn cooler. Like, you're not going to need a high burning spark plug or a high range spark plug here in Florida, but it'll come in really handy in Anchorage, Alaska. So that's pretty much it. Different threads are for different manufacturers. You know, obviously spark plug is not going to be the same for like the Chevy Colorado as it would be for Cadillac Eldorado. Might be a little bit different. And that's all I got. I'm going to go over a wiring diagram for ignition coil, for the ignition coil performance coming from this vehicle. This vehicle is for a 2006 Chevrolet Colorado 2.8 liter engine. So, starts right here. You got the ECM. So you got, if you look, trace the orange. Those are the reference wires that's going to give the commands to the ignition coils what they need to do. Then you have the power coming from the underhood fuse block. You see those are in pink. I know there's a lot going on over here. Those are all connected. They're in a series, and then you have everything grounded in a series right here that goes all the way over here to underhood fuse block as well. So, and it's pretty simple system. Turn the key on. ECM sends the signal out, sends it down to there. You got power provided from here, and that kind of completes the circuit. It's a very simple system. It's not very much to it. I think I got it covered with all the different colors. Obviously the loads are going to be, I have to say this, the load is going to be the coil packs themselves, and then, you know, we have a series of microprocessors and transistors inside the ECM. And for this part of the video, I'm done. So it's a simple way to do this because it's easier and less time consuming for the time constraints of the video. So what it is, you go to Spark Test. You have a little tool like this, a Spark Tester. You take the coil pack, and nominally this would be still attached to the wire in the vehicle. What you do is you plug the coil pack in, or the coil pack loop, over the spark plug tester. What you do is you would set it down, and don't touch the outside of it. You're going to put it down somewhere. You're going to turn the vehicle on. When you turn the vehicle on, you should literally see blue spark jumping out of here. It's pretty much as simple as that. It's going to let you know if this is working properly or not. It's one of the simplest tests you can do to determine a spark test and make sure your coil packs are operating properly. That's all for now. I have the coil pack already out of the vehicle, so it's a little bit easier for me to explain this way. So you're checking for voltage. What you're going to do is you're going to find the positive wire, and it actually tells you right here which wire is positive. You literally just, this will still be plugged into the vehicle. You're going to back plug, or you're going to back pin the plug in order to get the proper voltage. You should read with the vehicle on, it should be, I want to say, no, it should be 0. So you're going to back pin the positive, and then you're going to ground the other part of the multimeter somewhere else, and you should get 0. If you have anything other than 0, chances are you either have a bad wire somewhere or you have a bad spark plug. I do have to back pin the ground for the coil pack. You see here, the ground is a ground wire. You back pin it, you put it on the proper setting on the digital multimeter, and all you're literally going to do is this, and find a good solid ground somewhere, and it should give you a reading, whatever the reading may be. It's pretty simple. Someone needs to start the vehicle. I'm not going to go through that right now. I'm just showing you the proper procedure how to do it. How the ground path is already traced out from the ignition coil, so it's pretty simple. It's pretty. This is a pretty simple system. That's all. So using the I can't say the word, oscilloscope on this vehicle, you see how you back pin the reference wire, or signal wire. I'm sorry. Signal wire using the yellow lead, and then you ground out the other side anywhere on a good ground, and then when you have it properly set up, it tells you when the ignition is shutting off, when the injector is shutting off. I'm sorry, I should know that. When the injector is shutting off, and it's actually pretty easy if you know how to use this, and pretty much self-explanatory. Not everybody knows how to use it. I just learned it like a couple weeks ago. I'm not going to beat a dead horse with the wiring diagram. I've already been through that. Reading schematics is pretty easy, but it's helpful in order to know. You're looking here, looking at all the different wires, so you know which one is which and what goes to what. That concludes this entire video, and I hope you enjoy it because I enjoyed making it. So thank you.